Hello everyone, welcome to 1-5 SI and Metric System, Unit 1, Properties of Matter, Guided Notes. In this we will look at the guiding question, describe how the metric or SI system works. Starting in our notes, in order to standardize measurements around the world, scientists created and/or agreed upon the SI units, which are a modern form of the metric system. SI comes from the System International de Unités, or the International System of Units. No, that is not my first language up there, so there we go. These are the base units on the SI units, which is on the next slide or right below this section in your notes. All other metric units are derived from these. Prefixes are used to change the size of the unit. So we have them here and a few for you to fill in. You may notice that liters are not present here. Liters are technically derived from length, where you do length times width times height, which are all a measurement of length to get a volume. So it's based off of that. The metric system is a base 10 system, so it's convenient to convert between prefixes by simply moving the decimal point accordingly. I won't be showing you that except briefly because I want you to practice doing dimensional analysis. The base units that we most commonly use are liters, meters, and grams. Later in the year we will add moles to describe quantities and materials. Here we have a number line to help you visualize the decimal point moving, or to make relationships between the different systems. So here we have KHDA, and we have a wave to remember these. So we would say that King Henry died by drinking chocolate milk. Not that this is super accurate historically, but it's a good way to remember kilo, hecto, deca, the base unit, deci, centi, and milli in order. Okay? And then you just have to remember beyond that that mega is 3 steps bigger and micro is 2 steps smaller, and anything else on either side, it's always like not 2 steps, 3 steps smaller, 3 steps bigger, and everything else on either side is always 3 steps from there. Okay. So what this means is that these prefixes exist. B for base unit because it is by itself, so meaning it does not have a prefix in front of it. So we will look at this to help us visualize these things. Here's another way to visualize it and their meaning in the metric system. So here we have our IDs. So we're going to convert 0.2005 meters into centimeters. So looking at King Henry died by drinking chocolate milk. We are starting at meters, which is by itself, so that's the base unit, and we are going to convert it to centimeters. So base unit is here, centimeters is here. Kilo is on the bigger side, so this side is big for our units, and this side is small for our prefix for the units. So when we look at this and we want to say how many meters to how many centimeters, because that's what dimensional analysis is comparing the two and using units to get to our answer, the bigger number always gets the number 1, or the bigger unit always gets the 1. So the base unit, or meters, is more to the left, so it is bigger than centi, so it gets the number 1. Centi is 2 steps away, so it gets the number 100. 10 for each step. So now we are going to set up our dimensional analysis train track. We put what we're given in the very beginning. So this is a very organized, straightforward fraction that we're going to multiply. And we put at the end the unit we want to find. The end comes to the top, the beginning goes to the bottom. And then we use our conversion factor to fill in the numbers here. So 1 is next to meter, and 100 is next to centimeter. We would then multiply the top and divide the bottom. So multiplying across the top, you end up with 20.05 centimeters. And that would be our answer. We are practicing it this way because we will be using dimensional analysis for math that is not easy in the future. Looking at the next one, the I do, we have, again, King Henry died by drinking chocolate milk. We are starting at deciliters, which is here. Deciliters, I'm sorry. We are starting at deciliters, and we want to change into deciliters here. Okay, so deciliters to deciliters. Looking at it, deca is bigger, so it gets the 1. Deci is smaller, so it gets 2 zeros next to its 1. Setting up our train track. Our given, or what we start with, goes in the beginning, 23.08 deciliters. What we want to find, deciliters, goes at the end. Trade them. Okay, so deciliters on the top, deciliters on the bottom. And the reason we do that is so that way the units we start with cancel out. So deciliter has 100 in front of it. Deciliter has 1 from our conversion ratio. The deciliters cancel out. We multiply by 1, divide by 100, and we end up with 0.2308 deciliters. For the we do, scan the QR code, but I want you practicing with the dimensional analysis method here, or if you were taught proportional fractions, that is fine as well. You need to show your work, though, for these calculations. So scan the QR code, show your work. For the you do, you must show your work using either the fractions or the dimensional analysis. When you are all done, do not forget to do the closure, answer the guiding question at the end of your notes. If you are absent, you can either upload your notes to the Schoology assignment or save them for when you return.